Hey, geometry. I get to these lessons and I feel like I'm teaching algebra still, but this will make sense as we continue. So we're working with equations and graphs. We still have a parabola with our focus and our directrix. This particular problem, the image shows a parabola with focus 2, -2, with focus -2, 2, and directrix y equals 0, which is the x-axis. Points A, B, and C are on the parabola. Without using the Pythagorean theorem, find the distance from each plotted point to the parabola's focus. In the last lesson, we did that using the Pythagorean theorem. So we're not going to do that this time. So let's do this. Let's do A first. We're trying to find the distance from A to the focus. I can't do that without the Pythagorean theorem, except that I know the definition of focus and directrix, that the distance from A to the directrix is equal to the distance from A to the focus. And I know the distance from A to the directrix is 5 minus 0, which is 5. I can either count the squares or do the math with the y variable. Okay, so that distance is 5. B, I can do 10 minus 0, so the distance is 10, and that distance is equal to this distance, and it's 10. And then C. Can't really count the squares on that one, but I know that it's x minus, it's y minus, doing awesome, 0. Okay, so this distance is y minus 0, therefore that distance is y minus 0. Put 3 tick marks there. So that right there is what's pretty important. This 0 really isn't 0. It's the line y equals a value, which is the directrix. Can't spell. Yes, I'm going to take a second to fix that. So we can actually say it's y minus y sub d or something like that. The y value of the equation that's the directrix. And that's what we're going with today. So let's move on. We are working today to build an equation for a parabola. So the image here shows a parabola with focus 3, 2 and directrix y equals 0, which is the x-axis. Write an equation that would allow you to test whether a particular point x, y is on the parabola. So we've done this a little bit already. I don't know the value of this point, but I do know that those two line segments are equal, right? This line segment is y minus 0, and this line segment is a little bit harder. It was x minus 3, because those are the x coordinates, and y minus 2. Let me erase this mess. When we were working with the Pythagorean theorem in the last lesson, we said that this leg of the triangle's length is y minus 2. And this leg's length is x minus 3. I got the 2 right there, and I got the 3 right there. Now, when we use Pythagorean theorem, we say that a leg squared plus a leg squared has to equal c squared. Okay, we don't need c right now, but we're just going to stick with it for a second. Now, solving for c, I take the square root of both sides, and I get c equals, well, I can't take the square root of that big old messy thing, so we're just going to leave it. And right there, we have done number 1. Write an equation that would allow you to test whether a particular point is on the parabola. Okay, that equation is x minus 3 quantity squared plus y minus 2 quantity squared. We just developed what we like to call the distance formula. Really important. I'm not just joshing around with you. It's super important, right? All right, so that's number 1. Number 2 says the equation you wrote down defines a parabola, but it's not in a very easy to read form. Rewrite the equation to be in vertex form, which is super duper useful, where h and k is the vertex. So our vertex is right there, and we're going to call it h comma k. So h and k are, count that over, it's over 3 comma up 1. If we put that into what they call vertex form, we have y equals a, because I'm not sure what a is yet, x minus h, which is x minus 3 squared, plus k, which is 1. Okay, but what is a? Where do we get that value from? I'm going to get a new whiteboard and show you guys a little bit of math magic. Okay, so I'm asking you to stick with me here. Instead of c squared, we're going to write y squared equals x minus 3 squared plus y minus 1 squared. That is the y minus 2, sorry. That's the equation we came up with for question number 1. Okay, actually, because I still have y squared, I need to get rid of the square roots. Okay, that square root came from taking the square root of both sides. All right, I'm going to FOIL the y minus 2. Do you remember how to FOIL? First times first. Outer, inner, and last. So that gives me y squared equals x minus 3 squared plus y squared minus 4y, because I collect like terms, 4y plus 4. I can subtract I can subtract y squared from both sides. That gives me so far 0 equals x minus 3 squared minus 4y plus 1. Now, the vertex form they talk about is y equals a x minus h squared plus k. So far we're doing good. We've got this right there, but we need to move these around. So I need to move the 4y to the other side. We're getting closer, right? So now it looks like I might have this, but that is still a problem, and I have a 4 in front of the y here. So let's divide both sides by 4. I see a mistake here, sorry. So when I divide this by 4, those cancel. This 4 has to go underneath this part of the equation. There's a 1 here. And under this part of the equation. Because there's a plus, let's do this. That's a little too confusing. I'm going to start over a little bit. That gives me 4y equals x minus 3 squared plus 4. Now let's divide both sides by 4 a little bit. It makes a little bit better sense. When there's an addition in between two pieces of the expression, I have to divide that 4 by both separately. So that cancels. I'm left with y equals, I'm just going to bring that out front, 1/4 x minus 3 squared plus 1. And that right there is the equation that I'm looking for. Okay, they said that the vertex was h comma k, and I read it from the graph as, I have to look at the graph again, hold on, 3 comma 1. So that's how I knew that x minus 3 for h plus 1, that's squared. But the a term is still a little bit of a mystery as to how we come about it without doing all of this equation. Okay, we don't want to do that. Before we go back though, really quick, in this equation, the 3 and the negative 2 were obtained by the focus. And in this equation, the 3 was obtained by the vertex. Why is that? Well, interestingly enough, I didn't mean to do that, sorry. I just need a little bit more space. When you look at the graph, we have the vertex and the focus. The x values are both 3, so that's not a mistake. All right, now let's go back to the problem. So I've told you a little bit through that little whiteboard, lots of algebra going on. We have here y equals a times x minus 3 quantity squared plus 1, where this is h and that is k. Now a is something we are going to deal with. We'll be able to find it in a future lesson. But it does deal with the distance from the vertex to the directrix, where that distance looks like it is 1 unit. And a in this equation is 1/4. What I can write from the previous slide is this. Okay, so we're going to get to this a term in a future lesson because we don't want to go through all that algebra to come up with an equation for a parabola. Cool. All right, the last thing we have today is a card sort. And what I'd like you to do right now is go to Google Classroom. Everyone has a Google Doc in Google Classroom. When you open up that Google Doc, you'll get your own copy. I want you to sort the cards into what makes sense and then save it and turn it in. Okay, so that's it. You're going to get a set of cards with graphs and equations of parabolas. Match each graph with the equation that represents it. Awesome. That is all I have for today. Okay, I know that was a little heavy, but it's all going to make sense as I tie it all together with the next lesson.